hertz is 1 oscillation per second, which is a period of 1 second. So if I play them at the same time, let's figure out what the period is of the oscillation. So the difference in the frequencies is the frequency of what's called the beats, the beat frequency. Now, let's do 440 and 439.5. Anyone want to predict what the beat frequency is going to be?
Half second.
Half second.
And therefore, what will the period be?
1 second.
2
seconds.
2. Yeah, it's the reciprocal.
Yeah.
So here's 439.5 and 440. 1001, 1002, 1001, 1002.
Oh, it is though.
2 seconds.
So if we did like 439.75 and 440 would be 4 seconds.
Yes, if I heard the numbers correctly.
Yeah.
So if they're a quarter of a hertz off, it would be a 4-second beat. So the closer we are, the longer that beat frequency is going to be, or sorry, the smaller the beat frequency, the larger the beat period. So what we're going to do is we're going to play the 406.23, 213. We're going to play that, and I'm not expecting it to be exact, but if we are at least within the ballpark, there should be some sort of trill between them. So 406.213.
Oh, that's creepy.
Do you hear? There's a little bit. I'm listening for it, but do you hear a slight trill there?
Yeah.
Yeah.
All right, so we're in the ballpark at least, because we can hear the drill. So that's 406.21, and I'm just going to do, why don't I go 100? Let's see what that sounds like. So
406 and 100.
if I do 206 and 406, sorry, that's 200. If I do 306 and 406, can you hear a trill there? That's 306.
I like that. Just like the piano guy at church fell asleep.
All right. I can hear just a tiny bit of a trill. At some point, we might run into issues with the physical makeup of how the speaker is done. Now, supposedly, one physics textbook talked about that if you did a 20,000 hertz and 20,440 hertz at the same time, the beat frequency would be 440, and we should be able to hear the 440 hertz. I have not found any evidence to support that, but it was in one physics textbook. And
You want to?
because most sound generators limit it to within basically human hearing.
Yeah.
They're not letting, I'm not sure the speakers can handle
Oh.
20,000 hertz.
So like if you put, we wouldn't be able to hear it, but there'd be a difference you'd notice?
That's what the book claimed.
Is that
What?
Would that be true for any 440 difference? Like if you had like say
That's-
2,000 and 2,440, and you played them.
In theory.
I know that like digital has limitations for how much it can do. Like you can't just tell a computer to do 20,000 hertz. It's gotta be like, it's gotta be through an analog connection or something like that.
No.
Wait, so if you do like
Okay.
200 hertz and you did 640 hertz and you put them together, like
Can we do that?
can we try that?
200,
200 and 640.
there's 200,
What's the
and 640?
Yeah.
I feel bad about this.
See, I just hear two distinct
I'm not
tones.
gonna lie, you know.
Alright.
But it's possible that the 440 was there, but it was just being masked by the other two sounds. And so, or it could be that that physics textbook was just full of crap.
I think that's.
I mean,
There's some other things in that textbook that I
Right.
question as well.
the like if you were able to hear 20,000 hertz, and then if there's 440 hertz of difference, you hear it. But we're not gonna be able to hear that. Maybe we could get like a bat to prove it.
Or, you know, fancier equipment than what we have right here.
Yeah.
Robo bad.
All right, one thing that I am curious about is I'm gonna do I'm gonna bring up an ad here. All right, it's gonna start at 0 hertz and it's gonna go up to 20,000 hertz of whatever the speaker can handle. And so it'll start out below most, I think everyone's hearing, but very quickly it'll get into what you can hear. So when you can no longer hear it, just sort of put your hand up and down when you get to the point where you can't hear the high frequencies anymore. If it gets really bad, if you need to step outside to get farther away from it, I understand. That's not just for Wajia. Anybody, if it gets really bad,
Yeah.
Now, because I have tinnitus, I'm gonna lose it about 8,000 hertz to 10,000 hertz. I won't be able to hear it, but then I'll hear it briefly back again, and then I'll lose it again for good. When you just hand up and down with at the moment. 4,000 hertz. 5,000 hertz. 6,000. 7. Up, out. 9,000. 10,000.
Quickly though.
I can hear it again.
I can hear it still.
We're about at 12,000.
My ears are better than
13.
I'm out. That's where all the limit is for me.
All right, so 2 of you were out. We're at 16,000 hertz. You still going strong there?
No,
You're still hearing it? All right. And that's 20,000 hertz there. All right. I still hear the ringing. I think I was out sooner than I said, because it's a different ringing in my ear than there was when I started.
But that's pretty normal for everyone, right? Just right above 12,000.
With age.
Yeah, it gets worse.
You're in your 50s, sir? Which is why our parents couldn't hear the TV.
Yeah.
Typically, people with good human hearing it's somewhere around 200 hertz up to 19,000 hertz, 20,000 hertz, somewhere up there would be when you're in your prime hearing. And then it starts to degrade on the high side.
When are you in your prime hearing?
It depends,
Like when you're.
because your ears are so delicate. Like just being in the city and hearing trucks all day can mess up your hearing. Being in like loud cars can mess up your hearing.
Or listening to loud music, going to a lot of rock concerts.
Right.
You can listen to speakers.
Do you
It's
guys
like
have
damage to
more
the
kinds
little
of
hairs
headphones?
like that are really
That
deep
mess
in your
with your
eardrum,
hearing?
I think, is what causes.
That's what the bio people tell me. I had a different theory at one point, and I got a look from some of the bio people who, like, how is this person even surviving? I got an eye roll. It was a very good eye roll.
I trust you over them.
Yeah. I speculated that, because your eardrum's basically moving in and out when the sound wave hits it, or the pressure wave hits it, and that, over time, take a paper clip and you bend it back and forth, and at some point it's gonna get weaker and weaker. So I was speculating that the eardrum was getting stretched and taking the damage. But then they came back and said, I asked so-and-so, who, does it for a living, looks at that stuff for a living, and basically claiming I was wrong. So I just looked at them like they were crazy.
No, but the concept in and of itself does make sense.
Yeah, but I think it is the hairs that is the more dominant.
Yeah.
If the eardrum has any effect at all. There's gotta be a crazy scientist out there somewhere who agrees with me.
I just did some like quick research because I was curious, and the lowest note ever sang by somebody was like 0.1 hertz.
Wow.
Like,
What?
Not that anyone could tell.
yeah, like
They're lying.
Actually, I have some input on the lowest note in the song. Most of it is illegitimate because people, instead of actually singing the note, they just vibrate, like they fry their voice. Like it's not actually them singing it. So the world record, a few of the world records that Guinness thinks is the lowest note is actually wrong. In some people's eyes.
Yeah, that's not really legitimate. They're just vibrating their voice, which I guess is what sounds.
Is that what your
Yeah.
voice is?
But they're not really
But
singing.
it doesn't come from their chest. It comes
Right.
from like I don't really know how to explain it.
It's muscle control in the throat.
Yeah, exactly. Instead of it being like muscle control in the throat, they're pretty much just frying it without actually singing the note.
I don't know how you fry your throat.
So it doesn't come from like the vocal cords or something, it just comes from,
Your inner within.
I was thinking
No.
frying was that, that's frying where you deliberately put in a vibrato.
But
no,
Is that,
Pants with
It's
them.
obviously I've got ignorance in this room.
Mhm.
I don't know how to explain it, but I had someone explain it to me once, and essentially it's like if you're clearing your throat, that's like frying. That's like the frying that they're doing. Like that's not singing. You're clearing your throat, but
Right,
it's
just
a
sing a low
different type of noise that you're
oh,
making.
like they were like if they're trying to throw constantly to hit that. Yeah.
I think frying is a technical term, not as in your voice is fried forever.
That's what I
you
was
sound
thinking. I was like,
you
Oh,
sound
that's
like a
what I
little
thought.
rascal.
That's dedication
That's what I
there.
thought too. I was like, what? Yes.
All right,
I have a question.
yes.
Actually, I don't know if you'll be able to answer it or not, and I don't know if it happened to anybody else, but while you were playing it and it was going higher and higher, there was a point where it got physically painful to hear,
Yeah.
and then it stopped. Why
Yeah,
is that?
it
There-
started hurting.
Yeah.
So it got really loud,
I
yeah.
mean,
Yeah.
there are certain frequencies that people are sensitive to, just like there's certain
Oh,
smells that
okay.
people are very sensitive to.
Okay.
And I was listening to an NPR story the other day, and they talked about people with ringing in their ears, that's playing a certain frequency, and for some people, that frequency is that painful one. And so fortunately, I'm not listening to the painful sound all the time.
Wow.
That would be unfortunate.
Yeah.
Now, there was, years ago, I was working with the online tone generator. I was gonna do the demonstration for part of the class, and I had it at a really high frequency, and I couldn't hear it. It was like maybe 10,000 hertz. I wasn't hearing it. And so I was going about my business, and at some point, early, about a couple minutes into class, somebody said, "Does anyone else hear that high ringing sound?" And then I realized I didn't actually hit stop. So I turned that off. And then, and probably the most petty thing I've done is there were some high school students right outside my office, and they were being extra loud. So I put that thing on, 15,000 hertz, cranked the volume way up, couldn't hear it at all.
That's
Like
pretty
a
funny.
dog
whistle.
This is the advantage of getting older. So when you start losing that hearing, just recognize you've got that power now.
Yeah, at least if we were in a quiet place, we'd survive in here for a little bit.
Yeah.
Okay, let's make one more prediction with the tube, and then we'll move on to one fixed, one free end. So, third harmonic, the wavelength is gonna be 2/3 of the length.
0.837, and then 1 divided by 609.
Oh,
The wavelength
Yeah.
is 0.558, and then the frequency is 609.319 hertz.
Which should just be the sum of the first two that we did.
Yeah. Oh wait, it is. Shut
is true.
All right, so we have one more prediction here. So let's do this first. That's second. Third harmonic. That sounded like 609, right?
Yep.
I
know.
Dead
I
on.
was thinking 608, but
Oh, yeah. I see. I know what you're saying.
Possibly 609.2.
That would be tears of joy if you pulled that one off. Sorry about that. Oh,
I bet there's somebody out there that really can do that though.
probably.
They can just hear something and tell you what it
All right,
is.
so I'm gonna play that, we'll try to make it quick, so there's less pain.
Yeah, I hear that.
That's pretty.
It's pretty darn close. Like, it's not
That was closer than the other one was. Usually it gets worse and worse the farther we go, but that one actually seemed closer. So anyway, 2 free ends. Questions before we do one fixed, one free?
Do you have a demonstration object for that?
Oh, yes. Another lab that we will not do as a group. Sorry,
Let's go.
sorry, Chance.
Wait, we don't, or do we do have a lab?
That would, no. Just go grab the equipment right over here.
We have 2 tests next week.
I was like, we gotta have that.
I thought it was because we had a test today.
Yeah, that's kind of what. I know I didn't come in a hurry, but I was like, I bet there's a test today.
So I took my time.
We said the test.
No, I was like, I bet there's a test today, and I'm just.
There was a test originally scheduled for today, but we're doing that on the multiple choice next Monday. All right, so what we have here is, so you can see it right there. It's a sound tube, sound water tube, but I'm trying to remember exactly what the passcode calls it. But there's water in here. I can adjust the level of the water just by moving the cup so that water will seek its own level. So if I drop the cup, the water in the tube here is going down and the water in this cup is going up, and eventually they'll be at the same level.
Oh.
They'll move until the air pressure is,
Equal.
yeah, or the force is equal. All right. And so we can adjust the length of the water, or the height of the water in the tube, just by moving the cup. Now we'll need to add some more water. Apparently, it doesn't look like there's any in there, so I'm gonna need to go grab a cup and fill it.
There's that bottle of Bojangles water that's been there all semester.
Someone just feels disgusting about using that one, but I don't know why.
It's literally been sitting there.
Yeah, it
All right,
has.
so any germs would have died.
Lead blue?
All right, the downside of it is that you do get the metal on metal scraping, and
I can't stand the sound.
yeah,
That
I'm
sounds
not
good,
fond of it
man.
either.
That's kind of
Makes my teeth
That one's
hurt.
not bad for me. Foam on
That
foam
kinda
is
sound.
worse for me.
I don't think it sounds bad.
Here we go.
Okay. Oh,
Do it
that was
slowly.
pain- okay, that was
Oh,
better.
you
That
should
was a lot
probably
better than on the way down. That was awful.
There it goes.
Yeah, all right, so let's see.
Oh.
So I can pour water on either side, so there's no kink in the tube here.
Or whole.
Yeah, supposedly, well, there is tape around here. Actually, it's just-
Flex tape.
It's just a band of paper wrapped around it.
Oh.
Seems effective.
Wait. Oh my gosh.
Oh, got some air in there.
Hey.
I can see little particles floating around.
Yeah, the older ones are even more disgusting.
It's got
The
some
particles that.
chunks
It
of
reminds
mold.
me of a fish tank. All the nasty stuff comes
But the fish have all died. All right,
up.
so eventually,
No.
yeah, they're almost at the same level. All right. And that one. So basically, I'm gonna play a frequency.
I don't know if they can see it on camera.
I just flashes before them before. So
Oh.
basically now we have the water up to here, and it'd be the same level on both of them. I'm going to pull out the LabQuest and plug it in because you can't have too many things plugged in. Oh, uh-oh. Wait for that to come on. And it does do tone generator. I tend not to use that for the demonstration that we just did because it doesn't do fractions, it's all integral hertzes. Unlike online tone generator, which allows you to do decimals. And I'm gonna play a frequency, and the sound is gonna go down, it's gonna bounce against the water, and then come back up. So we'll have the waves going down, we'll have the waves coming back, so we'll get the interference patterns.
That's kind of crazy.
If we are at a harmonic, then at the tip right here, we're gonna have an antinode. The wave is the biggest modulation at this point, and which means that by the time it gets to your ear, it's the biggest push in and pull out. So the sound will be louder when the length of this matches the length of a harmonic. Or for those not seeing it, so we'll get a harmonic when the length from the top of the water to the top of the tube here matches the length of one of the harmonics.
Oh.
So let's now do our predictions. I have one fixed, that's this end down here, one free end. So what is the simplest pattern that we can draw?
Oh, well, like one of those with a closed end and one of them with an open end.
Okay, so my first harmonic, this is for one fixed, one free.
I like that description.
Basically, it looks like that.
Oh,
Is that what you were saying?
no, I was
Okay.
saying like you closed off on the first harmonic over there, you like closed off the left end and then you kept the right end open.
Ah, okay.
Oh, so it's.
That's actually the next harmonic.
Oh.
All right, so the first harmonic is right here. How many waves is this?
Is it a quarter?
Yep. So L is equal to a quarter of the wavelength, and so the wavelength